add negative 2/5 plus 1/2. So when you're adding fractions, remember you have to have a common denominator. So I'm going to line these up vertically. Now the common denominator of 5 and 2 is 10. So whatever change I make in the denominator, I need to make the same change in the numerator. So in order to make 5 10, I need to multiply by 2. So what I do to the denominator, again, I do to the numerator. So negative 2 times 2 is negative 4. So for 1/2, I need to multiply numerator and denominator by 5. So now, once I have my common denominator, my denominator stays the same, and I combine like terms in the numerator. In this case, I'm going to add negative 4 plus 5, which gives me 1. So my answer would be 1/10. Our next question, for each value of u, determine whether it is a solution to negative 13 equals 6u minus 1. So what we're going to do is take the value of u given in the table. For the first example, it's 9. And we're going to substitute it in for u in the original equation. So instead of it being negative 13 equals 6u minus 1, negative 13 would equal 6 times 9 minus 1. So if it is a solution, the left-hand side will equal the right-hand side. So let's go further and simplify. 6 times 9 is 54. And 54 minus 1 is 53. So negative 13 does not equal 53. Therefore, 9 is not a solution. Let's look at one more. I'll try negative 2 this time. So again, I come to my original equation, negative 13 equals 6u minus 1. And in place of u, I'm going to put negative 2 this time. So 6 times negative 2 is negative 12. And negative 12 minus 1 is negative 13. So since the left-hand side equals the right-hand side, negative 2 would be a solution. Now we're asked to solve a linear equation. We're given 3 equals 6 plus y. So what we always do when we're dealing with linear equations is work one side at a time. So we would remove parentheses, combine like terms on the left-hand side, and do the same on the right if they're there. If not, we do all that we can before we start isolating our variable. So there's nothing that I can do on the left-hand side. There's nothing I can do as far as combining like terms on the right-hand side. So now I need to isolate my variable. So I need to move or eliminate 6 from the right-hand side of the equal sign. So I do that by taking the opposite. What I do to one side, I do to the other side as well. So on the right-hand side, 6 minus 6 is 0. So that just leaves me with y. And on the left-hand side, I have 3 minus 6, which is a negative 3. So y would equal negative 3. You can always check your answer, and I'll do it for this one. We come back to our original problem, 3 equals 6 plus y, and we're going to replace negative 3 in for y. So similar to what we just did in the previous example, I'm looking to see if the left-hand side equals the right-hand side, So 6 plus negative 3 is positive 3. Since the left-hand side equals the right-hand side, my answer, negative 3, is a solution. My next problem. Solve for x. 3x equals 42. So again, if there was something to do on the left-hand side, I would do all that I can. Then on the right-hand side, I would do the same. But there's nothing to do in this particular problem as far as combining like terms or removing parentheses. So now I need to isolate my variable. It's already isolated. Nothing's being added to x, and x is by itself on the left hand side. So what I need to do, since I'm solving for 1x, is to do something to this coefficient to make it 1. So the easiest thing to do in this case is to divide, and what I do to one side I do to the other side as well. So 3 divided by 3 is 1, so that gives me 1x. And 42 divided by 3 is 14. So my answer for this problem is 14. And again, you can check this if you'd like. I'm replacing x with 14. And 3 times 14 is 42. So again, since the left-hand side equals the right-hand side, x equals 14 is my solution. The next problem. Solve for x. 2/7 x equals 14. So again, there's nothing to do on either side. So we're to our final step where we need to do something to the 2/7 so that our coefficient, the value in front of x, is 1. So yes, we could divide by 2/7. Dividing by a fraction is the same as multiplying by its reciprocal. So what I can do here is multiply both sides by the reciprocal of 2/7, which is 7 over 2. So I'm going to make 14 over 1, and again, multiply by 2/7. On the right-hand side, everything reduces to 1, so I have my 1x. And on the right-hand side, you can multiply first or you can reduce. I'm going to reduce. 2 goes into 2 one time and into 14, 7. So now I multiply straight across. 7 times 7 is 49. And 1 times 1 is 1. Any number over 1 is the number itself. So my answer would be 49. My next problem. Solve for u, and I have negative 2u equals negative 16. So again, nothing to do on either side. So I need to turn the coefficient in front of my u from a negative 2 to a positive 1. So I'm going to divide both sides by negative 2 because any number over itself is 1. So this becomes 1u on the left-hand side. And a negative over a negative is a positive, and 16 divided by 2 is 8. So my answer would be u equals 8. My next problem, solve for w. 160 equals the opposite of w, or negative 1w, plus 8. So remember, we do all that we can. There's nothing to do as far as combining like terms or eliminating parentheses. So now I need to isolate my variable. So I need to eliminate the positive 8 on the right-hand side by taking its opposite. So I'm going to subtract 8 from both sides. On the left-hand side, I have 160 minus 8, which is 152, and that equals the opposite of W, because positive 8 and negative 8 are 0. And remember, we're always solving for positive 1 W or whatever our variable is. So in order to change this from a negative W to a positive, I can either multiply or divide by negative 1. Because a negative over a negative is a positive, and remember, any value over 1 is that value. So in this case, W. And 152 over negative 1, a positive over a negative is a negative. And all this is going to do is change it to negative 152 as our answer. Our next problem, solve for V, and we have 10 equals 2V minus 2. So again, nothing to do as far as combining like terms on either side. So now we're going to isolate. So I need to get rid of the minus 2 by taking its opposite, and what I do to one side I do to the other side to balance the equation. So 10 plus 2 is 12, and that equals 2V, because the negative 2 and the positive 2 gives us 0. And now my last step, since I'm solving for a positive 1V, is to divide both sides by positive 2. So 12 divided by 2 is 6. And remember, any value over itself is 1, so that gives me 1V equals 6. My next problem. I have 2y plus 54 plus 4y equaling 6. So as I talk about in all these problems, we want to look at the left-hand side and do all that we can on the left-hand side, and then the right-hand side as well. So on the left-hand side, I have like terms of 2y and positive 4y. So 2y plus 4y gives me 6y plus 54 equals 6. So there's nothing else I can do as far as combining like terms on the left-hand side. There's nothing I can do on the right-hand side, so this is where you isolate your variable. So in order to isolate my y term, I need to move the 54 from the left-hand side to the right-hand side by taking its opposite. So on the left-hand side, 54 minus 54 is 0, just leaving me with 6y. And on the right-hand side, I have 6 minus 54, which leaves me negative 48. Now in our last step, we want our coefficient to be positive 1, so we're going to divide both sides by positive 6. So 1y equals a negative divided by a positive is a negative, and 48 divided by 6 is 8. So my answer would be y equals negative 8. Number 10, solve for y. We have 20 plus 17y equals negative 6 plus 15y. So we can't do anything on the left-hand side as far as combining like terms. Same thing on the right-hand side. So we need to isolate our variable. So you choose which side you want your variable to be on. There's no right or wrong answer. I'm going to isolate my variable on the left-hand side. So that means if there's any values of y in this case on the right-hand side, I need to move it to the left-hand side by taking the opposite. So that means I'm going to subtract 15y from both sides. So on the left hand side I have 20 plus, and 17 minus 15 gives me 2y. And on the right hand side, 15y minus 15y, remember, will cancel out. And now my variable isn't isolated yet because I need to get rid of that 20 on the left hand side. So since it's positive 20, I'm going to subtract 20 from both sides. And that leaves me 2y equaling negative 6 and negative 20 give me a negative 26. So now we're to our last step. We want our coefficient to be positive y. So we're going to divide by 2. So y would equal negative 26 divided by 2 is negative 13. Our next problem. Solve for u. We have 4 equaling negative 2u plus 4 times the quantity u plus 6. So again, nothing we can do on the left hand side, but on the right hand side we need to remove the parentheses and then combine like terms. When there is a value touching the parentheses directly, we take that value and distribute or multiply it times everything that's in parentheses. So the negative 2u stays as it is, and we distribute or multiply positive 4 times u, which is positive 4u, and positive 4 times positive 6, which is a positive 24. Next, we're going to combine like terms. So negative 2u plus 4u gives us a positive 2u, and we still have that plus 24. Okay, now we're at the step where we isolate our variable. So that means I need to eliminate the positive 24 on the right hand side by taking the opposite to both sides. So on the left hand side I have 4 minus 24u. Excuse me, it's just 4 minus 24, which is negative 20. On the right hand side I have 2u, and of course the 24s are eliminated. My last step, since I'm solving for positive 1u, I need to divide both sides by positive 2. So negative 20 divided by 2 is negative 10. And of course 2 divided by 2 is positive 1. So that gives me u equaling negative 10. Our next problem. Solve for v, and we have 2 times the quantity v plus 4 equaling negative 7v minus 1. So we're going to use the distributive property on the left hand side since that 2 is touching the parentheses. So I multiplied 2 times v, that gives me 2v, and 2 times 4 gives me positive 8. I can't do anything on the left hand side any further, nor can I do anything on the right hand side. So next we need to isolate our variable. I'm going to isolate my variable on the left hand side, so that means I need to eliminate that variable on the right hand side by taking its opposite. So on the left hand side I have 9v plus 8 equaling, and here negative 7v and positive 7v gives you 0, so that just leaves me a negative 1 on the right hand side. So in isolating my variable I need to eliminate the positive 8 by taking its opposite. That gives me 9v equaling -9. And then remember, we're solving for a positive 1v, so we're going to divide both sides by positive 9. So v would equal -9 divided by 9, which is -1. So our next problem, we have -3 times the quantity -5y plus 8 minus y equaling 2 times the quantity y minus 3 minus 3. So we work one side at a time. So on the left hand side, since I have -3 touching parentheses, I'm going to use the distributive property and multiply it times everything inside the parentheses. So -3 times -5 gives me positive 15y. -3 times positive 8 gives me -24. And I still have that minus y. Now I'm not going to do anything on the right hand side yet. I'm going to go ahead and combine my like terms. And I have 15y minus, this is the same thing as minus 1y. So 15 minus 1 gives me 14y, and I still have my minus 24. So I'm done with the left hand side. Now I'm going to focus on the right hand side. Remove parentheses, and again the two's touching parentheses, so I use the distributive property. So 2 times y is 2y, and 2 times -3 is -6, and I still have that other -3 that's on the outside of the parentheses. Combine like terms, so -6 and -3 gives me -9. And now you're going to isolate. So again, I choose to isolate my variable on the left hand side. So I need to eliminate the 2y from the right hand side by taking its opposite. So that gives me 12y minus 24 equaling -9. Next, I'm going to add 24 to both sides, because remember, you're isolating your variable. That gives me 12y equaling positive 15. And now remember, we're solving for positive 1y, so we're going to divide both sides by 12. So y would equal 15 over 12. But we always need to see if we can reduce the fraction. In this case, 3 divides into both 15 and 12. So I'm going to divide 3 out of each one. So 15 divided by 3 is 5. And 12 divided by 3 is 4.